Hi friends, welcome to the Unit 3 Day 1 notes. We're on Example 5. Example 5 talks about some application problems. First we're going to talk about fraternities at Steelhead University. So this is a actual common event that they've had in the past where they've basically tossed people on blankets. And this activity is actually borrowed from whaling villages of the Inuit Eskimos. So off to the side I've given you a formula. If you are unsure of a formula, look around. There's usually one listed. -16 I got from the gravity constant. T squared, T in this case is time. T is time. V sub naught, or V sub 0. That's how you say that. V sub naught. Naught is just a fancy way of saying 0. So V sub 0 is your initial velocity, or your starting velocity. And your H sub 0, or your H sub naught, is your initial height. So this particular instance talks about person traveling at 32 feet per second. This 32 feet per second is your initial velocity, and then they are standing at a height of 5 feet. Remember, so they're not starting at the ground at the ground level. They're actually starting at 5 feet before they throw them in the air. Write a function that models this situation. So I'm going to say f of t. This is a function over time. We said t is time, is equal to. So I'm capitalizing on this over here, this -16t squared. And then plus my initial velocity, 32t. And then they're 5 feet up off the air, so 5. This is how high is the person at 0.5 seconds and at 1.5 seconds. So I'm asking for their height. And because if I think about like this f, I'm actually going to go back to here, because I know that instead of being just like a function of time, I can say this is their height over time. So this gives me just a little bit more concrete function that models it. So how high is the person at 0.5 seconds and at 1.5 seconds? You plug in those values. So you're finding their height, then that means you're plugging in those values because you're given time. So if you're given time, plug in that to find the height. A lot of students will plug this in your calculator. When you do so, please make sure that you put parentheses around whenever you plug that in. So 0.5 squared plus 32 times 0.5 plus 5. So this gives me 17. So they're 17 feet at 0.5 seconds. They are 17 feet. And then what I'm doing here, a lot of students enjoy not having to retype the whole thing out. I'm pressing second, and then this entry button at the bottom just retypes the last thing that you have in. So I'm just going to go over and insert in 1.5 instead. Oops, got that flipped. There we go. 1.5. Press enter. That's also 17. So at 1.5 seconds, they are 17 feet. I should probably put 17 feet high. 17 feet high. There we go. What is the maximum height reach? And it says round to tenths. All right, let's think about what the maximum is. If I think about this graph, it has a negative a value. That means it's going something like this. Remember, they're starting a little bit higher off the ground, assuming hopefully the person doesn't ever hit the ground. That would be bad. So if I think this is the height over time, so this is time, this is height, this is their maximum. So the maximum is right there. That maximum is also the vertex. So what I'm really looking for here is I'm looking for the vertex. There's a lot of different ways to get to the vertex. You could convert this to vertex form by completing the square. You can find opposite b over 2a. I think that's going to be our best bet to go down for this one. So again, we're going to do opposite. It's in standard form here, so we're going to do opposite b over 2a. So A is -16, B is 32, C is 5. So opposite B over 2A, that's going to give us our x coordinate for our vertex. And that's what we want to know, because when is the maximum height reached? So here we go, opposite B, so that's going to be -32 over 2 times -16. That's going to be -32 over -32. Well, that's at 1. So this is 1 second. So at 1.0 seconds, the maximum height is reached. The max height is reached. to the nearest half of a foot, what was the maximum height? So now we're plugging in 1 into this equation to find it. So this is where we talk about where it's to find out the vertex of something. You might have seen a formula that's opposite b over 2a, and then f of opposite b over 2a. And what that means is this is your x coordinate, this is your x value, and then this is your y value. So what we're doing is we're plugging in whatever this was back into our original equation. Plugging in 1 back into our original equation gives us h of 1 is equal to negative 16 times 1 squared plus 32 times 1 plus 5. So negative 16 plus 32 plus 5, so 16 plus 5. So they reached 21 feet. They reached 21 feet. To the nearest tenth of a second, how long was the person airborne? So the person was airborne. If you think about the time, we want to know when this intercept is, because that's going to give us the time in seconds. If we also found the intercept, we would find this one here. Now this is backwards in time. They're never here because they never start touching the ground. They start in the blanket 5 feet off the ground. So we want to know this time here. How long was the person airborne? So we want to know what this x-intercept is. There's a lot of different ways to find the x-intercepts. You could go through the quadratic formula, factoring if it's possible. This one doesn't look like it's easily factorable. It might be. That's something to check. So just going through and solving using the quadratic formula might be the best bet. So we have x equals, I already have my a, b, and c here, opposite b, plus or minus square root of b squared, so 32 squared, minus 4 times a times c, all over 2 times a. So now we're just going to simplify this. X equals opposite b, plus or minus 32 squared eludes me, not one I have memorized, 1,024. And then 4 times 16 times 5, 320, so plus 320, all over negative 32. So if I take, I'm just going to try the square root of 1,024. Let's see, what's that? Plus 320. So, yeah, what's that going to be? Let's find out. X equals negative 32 plus or minus square root of 1,024 plus 320. Doesn't come out to be a nice value. Again, that is okay. What is that? 1,344? Yeah, 1,344. All over negative 30. So we want the positive one of this. We want the positive values. Remember, the negative one is here. So we want the positive one. So I'm going to do negative 32 plus square root of 1,344 divided by negative 32. So I put in the plus, and I want to show that this is not the correct answer. This is the negative one. So this is the one that's over on this side. So what I want, in fact, is the minus. So this tells me how long the person is in the air. X is approximately 2.14. So the nearest tenth of a second is about 2.1 seconds. So the person is airborne. For about 2.1 seconds. The profit from selling local ballet tickets depends on the ticket price. Using past receipts, we can find that the profit can be modeled by the function p of x, so profit of x, equals negative 15x squared plus 600x plus 60, where x is the price for each ticket. Find the ticket price that gives the maximum profit and also find the maximum profit. So what am I looking for when I'm looking for maximum? If you're looking for maximum or minimum, essentially you're looking for the vertex. So again, we can do our opposite b over 2a and f of opposite b over 2a to find that out. So we're going to take, let's see, opposite b over 2a. So that's going to be negative 600 over 2 times negative 15. It's It's negative 600 over negative 30. And it is 20. So 20 is the ticket price. So $20 is the ticket price. So then to find the maximum profit, we plug 20 back into this equation. So profit of 20 is equal to negative 15 times 20 squared plus 600 times 20 plus 60. So plugging this into my calculator, 20 quantity squared plus 600 times 20 plus 60. So I got $6,060. So at $20 per ticket, the maximum profit is 6,000. Oop, 6,000. Put that right. Comma in the right spot. $6,060. Whew, struggling. There we go. For this last one, Jennifer hit a golf ball from the ground and it followed the projectiles, where t is the time in seconds and h is the height. Find the highest point that her golf ball reached and also when it hit the ground again. Find a reasonable domain and range for this situation. So for this one, again, we're finding the vertex because we're finding the maximum. So if we find the vertex, we have opposite b over 2 times a. So we have negative 100 divided by negative 32. So this is going to be at 3.125 seconds. So that is the time. So we want to find the highest points. We need to plug in 3.125 into our equation to find the actual highest point. Plus 100 times 3.125. So negative 16 times 3.125 quantity squared plus 100 times 3.125. So that's going to be 156.25 feet. Find a reasonable domain and range for the situation. So again, the ball starting on the ground hits its maximum and it's going to hit the ground again. This is t, this is your h. So what we want to do is we want to find when the ball hits the ground again, so not at 0 time, but whenever this time is. So a couple ways to do that. You can use the quadratic formula, solve by factoring. By factoring is actually the easiest for this one. So what we want to do is we set y equal to 0 and then solve. So we have negative 16t squared. So this will give us our x-intercepts. Negative 16t squared plus 100t. What we can do is we can factor out a t from both of these, and possibly some even numbers as well. Let's see. Negative 16. So it looks like 2 can go into that. 4 can also go into both of those. Yep. So that's going to give me negative 4t. So then I'm left with 4t here, and then minus 25. So then we set each of these equal to 0 and then solve. So if I set negative 4t equal to 0 and then solve, that just gives me the 0. So that's the one I don't care about. What I do care about is the other one. 4t minus 25 equals 0. Add 25. 4t equals 25. Divide by 4. So 25 fourths is also 6.25 seconds. So 6.25 seconds is how long the ball is in air. Find a reasonable domain and range. Well, you know the height maximum. You know the time maximum. So domain is going to be from 0 to 6.25 seconds. And your range is going to be from 0 to 156.25 feet. There we go. The only thing I'm missing is writing it down in a sentence, but I'm almost out of recording time, so I will see you in the next video.